It's an INFM635 final project, Electronic Data Interchange Technologies in Health Informatics by Jamal Hawk. Rational assumption and justification. John has a breathing problems in the morning that persist into the day. He goes online and book appointment, goes to the doctor and explains his condition. The doctor checks his breathing assumingly and orders chest x-rays, blood tests, and suggests John sees a pulmonologist at the general hospital. The doctor sends the recommendation to the receptionist, assumingly stating that John needs to go see a pulmonologist. John requests that the receptionist book an appointment with the pulmonologist on the same day. The receptionist schedules his appointment for that day, and John leaves and meets with the pulmonologist at the general hospital. While there, he explains his breathing problems. The pulmonologist checks John's health record to see if there were any history of breathing problem, pulls the summaries of his chest x-rays, the blood test results he had previously gotten done at the initial doctor visit. Assumingly, the pulmonologist didn't have a clear answer as to what was causing John's breathing problem based off his initial test results from the doctor's office. He felt it was necessary to order a scratch test along with additional allergy blood tests. There are many assumptions that can be made throughout this scenario that are justifiable as well, such as John had two options to consult with his family doctor. He could call them and book an appointment or go online and book his own appointment. You can assume that 1, he called them and booked it because it's easier and takes less time. Or 2, he went online and booked it himself because the office is always busy and the receptionist never answers, and when they do answer, he gets placed on hold for a very long time. The scenario never mentioned anything about John registering. You can make assumptions that the reason for this is because he is an existing patient and his records is already on file, whereas only new patients are required to register. It also never states that the doctor actually checked John's breathing before he ordered a chest x-ray and blood test. You can assume that John went through triage before meeting with the doctor, or a doctor assistant came and they checked his lung and listened to his breathing. The pulmonologist ordered the scratch test and additional blood. You can assume that the reason for this was that the pulmonologist didn't have a clear answer as to what was causing John's breathing problems based off his initial test results from the doctor's office. When I was building up my use case model, I contemplated useful parcels. This comprised of me considering all the major utilitarian classes of the application that would help distinguish what zones I should be centered around. Thus, my initial step was to identify who would have been utilizing the system specifically. The general population that I distinguished were John, the receptionist, the doctor, the receptionist at the general hospital, and the pulmonologist. They are considered my actors within my use case model. They are the principal part of my use case, starting with John being my primary actor and everyone else being the secondary actors. After I recognized the system actors, I thought of a decent beginning stage to check the system configuration, distinguish who the system should help, and characterize what the actor needs to do with the system. In this way, everything that goes ahead in my use case managed the actor's association with the system. So I started with John going online to book an appointment, the reception confirming his appointment, and starting his registration. After John was registered, the doctor orders the chest x-rays along with blood work and requests John sees a pulmonologist. The receptionist schedules John's appointment with the pulmonologist. John arrives at the general hospital, confirms his appointment and identity with the receptionist there. He sees the pulmonologist, who checks his historical health, checks the summary of his chest x-rays and blood work results, orders a scratch test along with an additional allergy blood test. Every one of these things that the actors need to do with the system turns into a use case to recognize the use cases. I read the prerequisites particularly from an actor's viewpoint and carried on exchanges with those users who will work as actors. And by characterizing everything that each actor will have the capacity to do in connection with the system, I was able to define the functionality of the system. Sequence diagram. The sequence diagram are a kind of UML model that shows communication after some time. Sequence diagram delineate complex engineering, yet they can be shockingly simple to make. You can achieve a few basic undertakings with the sequence diagram, such as demonstrating the points of interest of a UML use case, show how an unpredictable strategy or system works, view how a protest and segment connects with each other in arrangement to finish a procedure. And also you can map out a genuine theoretical situation that has a wide range of parts. Now, to achieve these objectives, I initially distinguish the parts of my system that ought to be diagrammed. I set my objectives, which are my actors, on the canvas, and they are the vital players that perform errands and send messages. So once again, I had created my 5 objectives actors: John, the receptionist, the doctor, the receptionist at the general hospital, and the pulmonologist. The other arrangement of parts I distinguish are the messages the objects will send, which means which data is passed starting with one object then onto the next. In this graph, I caught the entire scenario and incorporated assumptions too. My sequence diagram demonstrates objects association orchestrated in time succession. It portrays the articles and classes engaged with the situation and the arrangement of messages traded between the items expected to complete the usefulness of the scenario. Sequence diagrams are ordinarily connected with the use case, acknowledged in a logical view of the system under development. But moreover, my sequence diagram appears as parallel vertical line, which is considered a lifeline, distinct procedures are items that live all the while, and as horizontal arrows, the messages traded between them and the request in which they happen. This enables the particular of the scenario to be in a graphical way. My activity diagram depicts the diagram parts of the system. It is essentially like a flow chart to represent the flow of one movement to another action, starting from John booking the appointment and ending with the pulmonologist ordering additional allergy blood work. These activities inside the movement can be portrayed as a task of the system. And on the off chance that you take a gander at the chart, you will see arrows going from left to right and descending. This is the control flow, which is attracted starting with one task and then on to the next. So before I begin my activity diagram, I needed to have an unmistakable comprehension about the components utilized as a part of movement graphs, which is simply the action. And presently, once I had the parameters, I expected to make a psychological design of the whole flow. And at that point, after I had the psychological design of how I needed the flow, I then transformed it into an activity diagram. And this way, I utilized my activity diagram to make a straightforward review of the situation to help other people better comprehend what's happening. And as I mentioned, my activity diagram has a begin and end node. And as I mapped out the functionalities of different procedures and systems, I needed to incorporate the particular moves that made place, the course of the controls flow, and the choice of the activities inside the scenario. HL7 version 2 and HL7 version 3. I chose HL7 version 2 as my missing implementation. Although I did both of them for extra credit, HL version 2, it was easier than version 3. I understood it from a terminology standpoint, which helped guide me through the process of putting it together. And because the messaging construct standard based upon pipe and hat encoding, it was easy to understand what was being said within the message. And what's more, being that this will probably be part of my major, the HL7 version 2 accompanies some evident advantages. For example, it supports most of the normal interfaces utilized as part of the human services industry, all inclusive, and it is utilized by 95% of the U.S. Healthcare Association. The challenge I faced, most of the challenges I faced was due to the system errors, in which of course you can see I took the screenshots of them. The system will have a blank browser, which is this one right here, or it will freeze up like this one, and it will also give me a message that will pop up, this message right here, and it will tell me to input a code. And when I do that, nothing would happen, and I pretty much couldn't fix none of them. So Peter and IT had to actually go into the system to do whatever they had to do, and once they got through doing that, the system was pretty much up and running in no time. But I do know with the third one where the message will pop up, only thing I had to do was let the system time out, and then once it timed out, I was able to log back in and everything was fine. And these are my references, and I hope you guys enjoyed the slide, the PowerPoint presentation, and that's it.